This video is about improving your support interface layer under a horizontal roof. And we all know when you don't have a horizontal roof, when you have a curved surface like this mask, that where the supports touch that underside surface is always going to be a bit rough when the supports are removed. And there's not much you can do on a curved or sloping surface, because the supports are constantly growing with each layer. But there are other kinds of parts where you can do something, and this is a good example here. This is one piece of a 3D printed U-joint. And you can see right here, it's got a D-shaped shaft. And this surface is what I call a horizontal roof. It's a flat surface that's elevated above the build plate. On one like this D-shaped shaft needs to be very precise, and because this fits inside an internal D-shaped hole, and if this is in bad condition here, then it's not going to fit or work well. I only need to support in this area. And I want the support to be very, very tight to the first layer of my printed part. And so that is controlled by the top Z distance. You see how it's set to 0 here? I'm going to set it to 1 mm and slice this so we can see the effect. So that top Z distance is the air gap between the top of your support layer and where the first layer of your part begins. And that air gap is supposed to cause less adhesion between the supports and your part. However, it also causes that first layer to sag, because when it prints this first layer of the part, it has to lay it on top of the support. And so, a normal value for the top Z distance might be like 0.1 or 0.15. But for this trick, I actually want it to be 0. I set that to 0. You can see from my other settings here in the spacing that I have tightened up this support. It's just a rectilinear support shape, but I've tightened it up so that it produces a very solid, smooth layer right before it prints the first layer of my part. I'm going to zoom in here and let you see this. You can see there's no gap between the support layer and my part, and that's what I want. So, here's what's going to happen. We're going to put a pause in this program between last support layer and the first layer of my part right there. And it's going to pick up and continue printing. And when it does, it's going to print that layer and continue on. And when this is sitting here, at this condition, when it pauses, we're going to put a bed weld material on the support layer. The one I like to use is called Layerneer. There are others that probably work. Layerneer is just the one that I started using, and it worked very well for me. It's a little bit sticky or tacky when it dries, which is good because when this continues printing, it starts laying down the first layer of my part that's going to be on top of the support structure. It needs to stick. A little bit. You don't want it sliding all around. If you use something that is a little bit tacky or that's slick like it's oil-based or wax-based, when it goes to print this, it won't stick to the support layer and it's just going to mess it all up and drag it all around. And I know this because I originally tried a wax material on this, and if it doesn't stick when it prints here, then you can't produce the part. It just won't stay in place. So we put the Layerneer on here, and then this continues printing and the layer here. It allows this layer, the first one on top of the support structure, to stick, but also to interfere with the molecular bond. So later we're able to break the support material off very clean. And you'll see in the example I'm going to show later that the first surface of our part here will be very smooth and very clean, which is what we're trying to get to. So here's the thing about these slicers. You would think if you were going to add a pause that you would add it right there. You would think, okay, print that and then pause. So you would think you need to be looking at this layer, but in fact the way the slicer works, you need to be looking at the first layer of the part itself that goes on top of the support. You right-click right there, hit the Add Pause, and then when you export the code and your machine runs it, it will actually stop between that layer and that layer. But you need to be looking at that one when you right-click and put the pause in order for it to work correctly. Here's Layerneer as it's found on Amazon. You can dispense this with the tip that comes on it. It's a foam tip, but it's a little bit big for working with a small area. So if you have a very small or detailed place you need to apply this, I found it to be easier to use these dispensing pens, which are also on Amazon. And you can fill them up and then the liquid seeps into the porous tip and you can apply it to small areas. To fill the pen, disassemble the pen by unscrewing the top. Take the top foam applicator off the Layerneer bottle. Fill the pen part way with Layerneer and put it all back together. On a Bamboo Lab printer, when it reads a pause command, it stops printing and gives this message. When you first fill up one of these pins, you have to hold down this plunger for quite a long time to allow the fluid to saturate that piece of material there. Apply it very carefully to the top of the support material, taking great care not to get it on any of the surfaces of the part you're trying to print. Give it a minute to dry before you continue printing. When the printer starts printing in here, if you've applied the Layerneer correctly and allowed it to dry properly, then the first layer of your part will print on top of the supports just like it was printing on the build plate. Here you can see the part printed on the build plate. Break it loose and use a blade to separate the support material from the part itself. The support material separates easily, and the part interface surface is relatively smooth and flat, showing only some light lines from the support material.